So for today, we need to move to density. That's what I want us to cover today. I had shared some questions on the same, though I didn't receive any feedback to know whether you met any challenge or you were able to handle them well. Was there any challenge that you met during your exploration of the questions I shared? Did you meet any challenge?
Teacher, on my side, I didn't do, but I promise to. I'll do some, then send you.
Okay. So some of the questions were covering even up to density, which we haven't yet covered, but once we will cover it today, I hope now it will become much more easier for us to handle them. So just a reminder concerning mass, we say that mass of an object is the quantity of matter on it, which is usually measured in kilograms, but there are other units whereby kilogram is the SI unit, which is the standard, and it's the recognized unit that is usually used across the world. So the other units which you can be able to use is grams, decigrams, hectograms, then we also have tons, megagrams, and so on. And then you are able to determine how to convert from one unit of mass to another, whereby we gave a table which you can be able to use to convert those units. And also you went ahead and discussed about weight, whereby you'll be able to understand that weight of an object is the pull of the earth on it, or it can be defined as the pull of gravity on an object, whereby it's given by, you'll be able to understand that weight is given by the mass times the gravitational pull or the gravitational force, or we call it just gravitation. And this gravitation is a constant, which is approximately 9.8 newtons per kilogram. This is a constant which we usually use. At times we can usually round it off to at least 10 newtons per kilogram. So therefore, you are able to discuss that once you are given either the mass and you are required to determine the weight, you simply take the mass given in kilograms, you multiply it by the gravitational force, which is given as either 9.8 or when it's rounded off to 10 newtons per kg for easier calculation. So I hope that one you are well conversant with it. Then the other thing which is very important is that you were able to understand that the gravitational force or the gravitational pull is different from place to place. For example, we'll be able to understand that various planets have different gravitational force. Like now, when you move to planet Mars, you realize that its gravitational force is different. So therefore, it's going to affect the weight of an object when in mass. The same case, if you go to the moon, the gravitational pull will be different. So meaning that in every equation that will be given, the constant G, which is the gravitational force, will be provided depending on which place or which planet that you are required to determine it's the body's weight or the object's weight. For example, as you can be able to see on question 4, the force of gravity on the moon is 1/6 of that on the earth. What would a mass of 50 kg weigh? So that's an example whereby you see that the force of gravity of the moon is 1/6. So it means that it's 1/6 of the moon, the earth's gravity, which is 10 or 9.8. So when you multiply that, you'll be able to get the gravitational force of the earth. So let's move to today's part, which we are required to handle, which involves density. Density is defined as the mass of a unit cube of a substance, or we can be able to define it as density is the mass per unit volume, That simply means that for us to determine the density of a body, we usually need the body's mass, and also we need the body's volume, which leads us to a formula, which is density equals to the mass divided by the volume of the given body. And remember that when we are dealing with the density, from the formula, we will be able to derive the unit, whereby mass is usually measured in kilograms, volume is usually measured in cubic meters. So therefore, the SI unit of density is going to be given by kilogram per cubic meter, which is a unit that is derived from the volume. Kilogram represents the mass, cubic meter represents the volume. Then another thing that we need to note on the density is that the density can also be measured in grams per meter cubic, or we can also be able to measure it in grams per liter or kilograms per liter. So meaning that density is usually given and it's derived from the formula determining its density. So once you have this formula of density, we can also manipulate it to other forms, whereby we will be able to have, now for us to determine the mass from here, we are going to multiply both sides by volume, so on this other side by volume, whereby the volume on the right hand side will be able to cancel with this volume that we have multiplied, such that now mass will be equal to the second formula, which is given here, density times volume. Again, you can be asked to determine the volume. Therefore, using the first formula here, we can be able to determine or to derive the formula of determining volume, whereby we can multiply again the volume on both sides, also multiply the volume here, so that the volume on this side cancels, we remain with the mass. So since we need the volume, we can be able to divide by the density on both sides so that we can remain with volume. So therefore, that one leads us to the formula given here, as the volume of a substance will be given as the mass divided by the density, whereby if the mass is in kilograms and also the density is in kilograms per cubic meter. This one will be able to derive us or to lead us to the density of volume, whereby we know that kilogram divided by kilogram per cubic meter is simply the same as changing this one to a multiplication and then finding the reciprocal of the second expression. So we'll be able to have kilogram equals times cubic meters all over kilogram, such that now the kilogram and kilogram cancel. So that reads us the formula. I want us to look at the units of conversion for density. We only have one, whereby we'll be able to understand that 1 gram per cubic centimeter will simply be equal to 1000 kg per cubic meter. That is the SI unit or the unit of conversion that we can be able to use in determining or converting from gram per cubic meter to kilogram per cubic meter, or from kilogram per cubic meter to gram per cubic centimeter. Example that we have here is find the mass of an ice cube of side centimeters, 6 centimeters, if the density of ice is 0.9 grams per centimeter cubic. The first thing that you need to do here is to find the volume of the cube. We know that the volume of a cube is given by the length of one side times side times side. In simple terms, it's the same as side cubed. So the volume will be able to, or will be simply be equal to 6 times 6 times 6, which gives us 216 centimeters cubic. So for us to get the mass from the formula is given by the density times the volume, whereby it will be equal to 216 times 0.92 grams per cubic centimeter. Remember, when working out these questions, you must ensure that the units that you are using are uniform. Like in this case, this one is in centimeter cubic, and the density given is in grams per centimeter cubic, so that one is uniform. So when you multiply, you will get 198.72 grams. The same time, we have been given that find the volume of a coke of mass 48 grams, given that density of coke is 0.24 grams per centimeter cubic. Therefore, from the formula that we have here is that the volume is given by mass all over density, whereby the mass is 48 grams divided by the density, which is 0.24. So when you divide that, you will simply, or it will lead you to 200 cubic centimeters as the volume. I think that one is a bit simpler. If you find that it might be difficult for you to remember this formula, there's this triangle here which will assist you to remember it on a very fast way, whereby at the top here you'll be able to have mass, and then below here you can have density, and then volume, whereby if you need to come up with the formula of mass, you will simply cover that of mass, such that now we say mass will be equal to this horizontal line here represents division. And then this vertical line here represents multiplication. So in this case, if you cover the mass, you are going to remain with density, then the horizontal line, and velocity, meaning that mass will be given by density times velocity. If you need to determine the density, you cover the density, and then you will see you remain with m, and then the horizontal line and velocity, meaning that density will be given by mass over v. And then if you need v, you will cover it, and then you will realize that you remain with m, the horizontal line, and d. So meaning that v will be equal to m over d, whereby m represents the mass and d represents the density. So this triangle here, if you can be able to have it somewhere, it will be able to be much help in remembering those formulas.
Teacher, I have a question.
Yes.
In example 1, as you have been told to find the mass of ice cube of side 6. So what if kama ingekuwa ni meters, as you said, it means the answer that is to the volume that is 216, we'll have to change it into meters. See, that's right, Amma? Is it that way?
Yeah, if you have been given,
change.
Yes, you have to change it back to centimeters so that they will be in uniform. For example, now you can be given the length of this ice cube to be in meters. So what you will be required to do here, since the density given is in gram per centimeter cubic, you have to make sure that either the length of the ice or the volume of the ice is calculated in centimeters to match that of the density, or you can calculate the volume in meters and also change the density into kilograms per meter cubic such that they will be uniform for easier calculation.
Okay.
Yeah. Then looking at the next example given or provided here, we are told a rectangular slab of glass measures 8 centimeters by 2 centimeters by 14 centimeters and has a mass of 610 grams. Calculate the density of glass in kilograms per meter cubic. For this one, we have two ways in which you can be able to do it. The first one, the units given or the dimensions given are in centimeters and grams, so meaning that you can find the density in grams per cubic centimeter, then we convert it to kilogram per cubic meter. Or the other way is we can decide, we convert the dimensions given into meters and then the mass into kilograms. Then we calculate it directly in kilograms per meter cubic. So let's use the first method whereby we find it the way it is, then we convert, whereby we say the first step is to find the volume, whereby the volume is given by length times width times height, whereby the length given here is 8 times 12 times 14. Those with the calculator, can you give me the answer there? 8 times 12 times 14. What did you get?
1,344.
1,344 centimeters cubic. Then the next step is you find now the density, whereby we know that density is given by mass all over the volume. The mass we have here is 610 grams divided by the volume which we have gotten here as 1,344 centimeters cubic. So when you divide that, what did you get? Do it from your end and give me the answer.
Zero 0.4538.
0.4.
Yeah,
Okay.
Teacher, I think there is a
0.45.
mistake somewhere.
Yes, where?
It is 8 times 2 times 14. Or is it 12? No, it is not 12. It is 2.
Oh, sorry. I think I overlooked that. So we change that. Here it's 2. So 8 times 2 times 14 gives us
224.
200 and
24.
thank you for the reminder. So here, once we change that, we will have here 224. Thank you. Then when we divide the 224, what did you get?
Two 2.723. 7232.
2.72382.
2.7232. 2.7232, not 8.
32. Yeah, so once you got this one, you can be able to give your answer in 4 significant figures, whereby it will be equal to 2.723 grams per cubic centimeter. So this is the question.
We have been
Yes.
told to give in kg, kilograms per meter
The
cube.
question, yeah, it is saying we give the density in kilogram per meter cubic, and we didn't change we tumefanya tu na centimeter cubic. Can we change it to meter cubic kama or meters?
That's where I'm next, whereby I say that there are 2 ways. This is the first one, whereby once you get your answer in grams per cubic centimeter, you can change using the units that we said, the one that is provided at the top here, whereby 1 gram per centimeter cubic is equivalent to 1,000 kilograms per meter cubic. So using that, we can change this one to kilogram per meter cubic, whereby we say, allow me to clear what we have here. So we say, since we have our density in grams, which is 2.723 grams per cubic centimeter. So we know that 1 gram per cubic centimeter is equivalent to 1,000 grams per cubic centimeter. Sorry, kilograms. Sorry for that. is equals to 1,000 kilograms per meter cubic. How about 2.723 grams per cubic centimeter? So when you cross multiply, you will simply have 2.723 times 1,000 divided by 1. So when you multiply that, it will simply lead you to 2,723 kilograms per cubic meter. That's the first method which you can be able to use. Or the other one is you can convert these units to the SI units. Then from there you calculate why it is in the unit that you need, like in kilograms and meters. So let's convert 8 centimeters. When you convert it to meters, it will be 0.08. When you convert 2, it will be 0.02. And when you convert 14, it will be 0.14 meters. And then we also convert the mass into kg. So 610 grams. When you convert it into kg, whereby we know that 1 kilogram is equivalent to 1,000 grams. How about 610 grams? So when you cross multiply that, it will simply lead you to having 0.61 kg. So now we find the volume. The volume will be given by length times width times height. So our length here is 0.08 times our width, which is 0.02 times the height, which is 0.14. What does that give you from your calculator?
Teacher, we are multiplying with 0.08 times 0.002 times 0.14.
Yes.
Okay. 2.24 raised to 10 negative 0.4.
0.24 times 10 raised to power
times 10 negative
raised to
4.
power. Then now we will be able to determine the density using the formula. Density is equals to mass over volume. So our mass here is what we got here, which is 0.61 divided by the volume which we have here, which is 2.24 times 10 to power negative 4. What did you get?
$2.723 times 10 raised to negative negative 0.05.
negative. I think there must be an error in your calculation.
Yes, yes.
When using a calculator in such a calculations, you need to note this. For example, in this lower part here, it has two parts which are separated by multiplication. So meaning that you have to use brackets so that the calculator understands that you are dividing everything that is outside. So you must include the bracket. So
Okay.
you write,
Mine
you
is
write 0.
23.
Yes, yours is
2723.21.
27, 23 point.
21.
Yes, that's the correct one. Yeah, I was explaining that
I didn't the bracket.
sorry.
I didn't use the bracket.
Yeah.
I did the bracket. That's
Good. Now I think you understand that. I think I can just explain what I was saying. Is that when we don't use the brackets, the calculator simply assumes that you are dividing 0.61 by 2.24. Then the result that it gets, it multiplies it by 10 to the power of -4. So that's why you are getting what you got, which is 2.723 times 10 power -5. But I hope you have now gotten the idea.
yes, yes.
Thank you. Yeah, so simply when you use the two methods, it's you to choose which one will be faster for you and which one will be easier from your end. The next thing is about the conversion, which I think we have already done. And from this example, what they have given here, I think they have made a slight mistake here. The first part, they got 2.24 as the volume, but the mistake that they made is they used 2.44 instead of they used 244 instead of 224. That's why they are getting a different answer from what we have gotten. But the correct answer is what we got. This one has an error. You should note that so that it should not confuse you. So can we attempt one of the questions here? In part exercise 15.3, I wish we attempt number 1, Roman 4, this one here. And we also attempt number B, number 1B, Roman 5. Yeah, you attempt it from your end. Then we'll be able to look at it together. You convert using the unit of conversion which you mentioned. The one which was 1 gram per cubic centimeter equals to 1,000 kilograms per cubic meter. I give you 2 minutes. once you are done, you notify me either through the chat section or you can unmute and speak something. What you got? Yes, I can see the response from Monica. So you haven't mentioned which number that is, the one that you have answered.
First one. Question
first-
1A, Roman. Yes. I'm doing the second one.
Okay. Let's try to be a bit faster. I'm waiting for the responses from the others. Charity, Domitila, and Wendo. Waiting for your responses. Thank you, Domitila. Let's see. You have your answers 19.3 grams per centimeter cubic. Thank you, Charity. Thank you, Monica. Okay. Yeah, so looking at the first case, where we have that, we convert or we express in grams per cubic centimeter. We have been given 19,300 kilograms per cubic meter. So we have that 1 gram per cubic centimeter is equivalent to 1,000 kilograms per cubic meter. How about the 19,300 kilograms per cubic meter? So when you cross multiply, remember when we are converting this one, we will make sure that the ones which have the same units are written on the same side. That's why we have this one as 1,000 kilograms per cubic meter, and this other one is 19,300 kilograms per cubic meter. So when you cross multiply, you are simply going to take this here, multiply with this one, and then this one, multiplying with this part here, which is not there. So we'll be able to have 1 gram per centimeter cubic times 19,300 per kilogram per meter cubic, then divided by 1,000 kilograms per cubic meter. So the kilogram and kilogram per meter cubic cancels. So we remain with 1 gram per centimeter cubic times 19,300. So these 2 zeros, this one cancels. So we remain with 193 over 10. So it becomes 19.3 over 10 grams per centimeter cubic, which is equivalent to 19.3 grams per cubic centimeter as our answer to question 1A, Roman 4. I hope that one is well understood.
Yes.
Thank you. The next one is B, Roman 5. Though I can see Monica did Roman 1, which is correct, and also others did Roman 5. So Roman 1, we have it that 1 gram per cubic centimeter is equivalent to 1000 kg per cubic meter. So this one also, we are converting it to kilograms per meter cubic. How about the 0.8 gram per cubic centimeter? So when you cross multiply, you have 0.8 times 1000 divided by 1, which simply gives us 800 grams, kilograms per cubic meter.
Teacher, which one? You said B, Roman 5.
Yes, though I am saying because Monica did Roman 1, that's why I've
Okay.
done it. Yeah.
It's okay. It's okay.
Then the second one is Roman 5, which is 450. So the same case, we say 1 gram per cubic centimeter is equivalent to 1000 kilograms per cubic meter. So how about 450 grams per cubic centimeter? So when you cross multiply, you have 450 grams per centimeter cubic times 1000 divided by 1 gram per cubic centimeter. So we'll be able to have our final answer as 450,000 kilograms per cubic meter in the second part. Hope we have followed up to that end and we are okay.
Yes, sir.
Thank you. This is the next question, which I want us to just handle one or two, then we can move to another thing. And when I look across, we can attempt number 2, which says, can we have someone reading for us number 2 from the group?
Question 2.
Yes, question 2.
What is the mass? See, it is that question, sir. Question 2.
Yes.
What is the mass of water that can fill a cylindrical tank whose diameter and height is 2.8 meter and 3 meter respectively? Take density of water as 1 kilogram per liter.
Yes, you can see this one is a bit different from the ones that we have handled from above. We have been given the density of water as 1 kilogram per liter. And then we have been given the cylindrical tank whose diameter is 28 meters and the height 3 meters. So we are required to determine the mass. This one is not that hard. It's only that you need to understand the previous concepts that we discussed on that one of we call it what? Mass. Whereby you need to convert the unit that we have been given, which is the density. You convert it to the SI unit. Then from there you can calculate, or you can calculate it with it the way it is. Then at the end you convert. So in this case we will say, first find the volume. Volume is given by, this is a cylinder. Someone to remind us the formula for determining the volume of a cylinder? Anyone?
2 pi
From
r.
the book? It is given as
2 pi r height.
you are saying 2 pi?
2 pi
Go ahead.
r
Yes.
squared times height.
2 pi r squared times height. Do you agree with that? The rest of us, do we agree? Do we agree with that formula?
Two pi r
Please.
height. 2 pi r height.
2 pi r height. This way.
Yes.
Do we agree? So I think I want us to see which one is the correct one between the two. For me, I can say that they are not, both of them are not right, because of the first one we have. Yes,
We remove the two.
we remove.
And then we remove the first two. Then we write pi r squared height.
Very good. We remove these two here so that we remain with pi r squared h, because we are required to find that of we are simply required to find the volume. So the volume is given by the base sorry, allow me to do something here. Yes. So I was saying that the volume of a cylinder is given by the base area times the height, whereby the base area is the area of a circle, and the area of a circle is given by pi r squared 10 times the height. So that is where we have as pi r squared and not 2 pi. When we talk of 2 pi is when we are determining the surface area of a closed cylinder, whereby we use it as pi 2 pi r squared plus pi d h. That's when we are finding, we will be able to remind ourselves that. So we have this volume given as 22 over 7 times the radius, which is 1.4 squared, times the height, which is 3. So what is it, or what are we going to get when we carry out that operation. 22/7 times 1.4 squared times 3. So let's attempt that.
$18.48
18
centimeter. 18.48.
Thank you. So we get 18.48 because the units that we have been given here are meters, so it will be cubic meter. Then we are not yet done. We need to determine the mass. So we know that mass is given by the density times the volume. The density given here is in kg per cubic meter. So we can change this one into liters, or we change the density into kilograms per meter cubic. So how can we change that? We know that this one is the same as when we have been given 1 kg per liter is the same as 1 kg divided by 1 liter. So we can change this one to cubic meters. So we know that 1 cubic meter is equivalent to 1,000 liters. How about 1 liter? It will be equivalent to how many cubic meters? So when you cross multiply, you are going to have 1 meter cubic times 1 liter divided by 1,000 liters. So that one is 0.001 liters. Cubic meters. Then use it to convert to the kg. Whereby we know that since 1 kg is equivalent to 1 liter, and we have got that 1 liter is equivalent to 0.001 meters cubic. So we divide by here by 0.001 cubic meter. So this gives us, when you divide that, you get it as 1,000 kg.
So please come again. I
cubic
haven't
meter.
understood them. From the grams per liter.
This part here.
Yes.
Yeah, so in that part, what you need to understand here is, since this one is in liters, and it's the only part which we need to convert, so we need to change the liters into cubic meters. From the previous topic of mass, conversion of units from mass of a kg to liters, that's capacity, we say that 1 cubic meter is equivalent to 1,000 liters. How about 1 liter? It will be equal to how many cubic meters? So when you cross multiply, you're going to have 1 cubic meter times 1 liter divided by 1,000, which gives us 0.001 cubic meters. Now, since we have already understood that 1 liter is equivalent to 0.001 cubic meters, we can replace this 1 liter with 0.001 cubic meters. So when you replace it, it gives you 1 kg or over 0.001 cubic meters, which when you simplify, it leads us to 1,000 kilograms per cubic meter. I hope now you have understood.
Yes.
Yes, thank you. So then from there now, we will be able to have it as since we got the volume was 18.48 meters cubic. So we need to determine the mass. Mass will be equal to 18.48 times 1,000. So which gives us 18,480 kilograms. That becomes the mass which we are required to determine. So I hope we are okay with that. Are we? Are we okay?
Teacher, we have multiplied the 18.48 meter cubic times 1,000.
Yes. And we have
To
gotten
change
it as
kg.
sorry?
To change it to kg.
No, we are determining the mass.
Oh,
Mass is
okay.
given by density times the volume, and the density of water that you are given is this one, which is 1 kg per liter. So we had to change this one to kg per cubic meters, which we got it here as 1,000 kilograms per cubic meters as the density. So when we multiply the volume by the density, gives us 18,408 kilograms. The density is measured, the mass is measured in kilograms. And that's what we got. Yeah. So I hope we are okay with that.
Yes.
Can you find us another example? Sorry. Do then you give us one.
Before I do a similar example, I want us to move to question 11. Someone to read for us that question. 11. It's still the same thing,
200.
concept, but it is with mixtures.
Number 11.
Yes.
Question 11. 2,000 centimeter cubic of a mixture consists of 2.5 kilogram of substance A and 7.5 kg of substance B. Find the density of the mixture in grams per centimeter cubic.
Yes. Is there anyone who is capable of doing that? The density of the mixture. Anyone with an idea before we do it together?
Teacher, I think we have a volume. 2,000 is a volume.
Yes.
Then we are told to find density. But
yes.
And we know the formula. The formula is volume is equals to mass over density. Now, so we can find the mass of the substances of substance A and B. Though that one of B we are not given.
We have been given
Somehow.
we have been given the mass of substance A and of substance
Oh,
B.
yeah, then that is our mass. Given mass, we have mass and volume, we can find density.
How? What I want to hear is, since we have two substances here, which is the
volume and mass.
yes, which is the appropriate formula for this one? We have been given the
We add
Oh,
the mass of A and B. Then we divide by the volume of both the 2000.
Yes, that's very good. But you need to also make sure that the units are uniform, as we had highlighted earlier. So you have to convert either, since we are required to have the mixture in grams per cubic centimeter, so we have to convert the mass into grams. Si tuko sawa hapo?
Yes.
Whereby we say the density is given by the total mass all over, that's the total mass of the mixture all over the total volume of the mixture. So the total mass will be given by 2.5 kg. When you convert it to grams, you get it as 2,500 grams plus the mass of substance B, which is also 7,500 grams. So when you add the two, it gives us 10,000 grams. So therefore, the density of the mixture will be, which is the total mass, which is 10,000 grams divided by the volume, which is 2,000 centimeters cubic. When we divide that, what do we get from your end? It gives us
5 grams per centimeter cube.
very good, 5 grams per centimeter cube. That is the density of the mixture. So that one is a bit easier, but there will be some situations whereby you'll be given the density of a given substance, and then you are given the volume, and another substance you are given also the density, and you are given the mass, and then you are asked to determine the volume of the mixture. So you have to find the individual volumes of the two substances, you add them to give you the total volume. Then you also find or determine the individual mass of the two substances, you add them. Then you divide, given the sum of the masses divided by the sum of the volumes. So you need to get the density of the mixture. So since that one is well taken, see, you can attempt question 3, which says that a cylindrical milk churn contains 15 liters of milk. Find the density of milk in grams per cubic centimeters if the total mass of milk in the churn is 14 kg. Can attempt that? That's number 3. Is it doable?
Yeah, trying, teacher.
Okay. Yes, what are we getting? Confirm your answers. We're taking a bit long to respond. Let's try to be faster, please.
Okay.
Teacher, my answer is 1071.42.
You have it as 1000.
1071.43.
1.43. And the other one is getting 23,333. Then the other one is getting 93. Which one is this? 933.3 grams per cubic centimeters. Okay. Thank you. Sorry. Sorry, my screen has disappeared, but 1 minute, I'll be sharing it back. Yeah, here it is. Whereby we will be able to say that we are required to determine the density, whereby the density is given by the mass over the volume. The mass given is 14 kg. And we need the density in kilograms, grams per centimeter cubic. So converting this one into grams, we know that 1 kg is equivalent to 1000 grams. How about 14 kg? So when you cross multiply, you're going to have 14,000 kg. The volume given, we have been given the capacity of
14,000 grams, teacher.
Sorry, thank you. 14,000 grams here, not kg. 14,000 grams. Then we need to determine the capacity that we have been given here, convert it to the volume in centimeters cubic. So we know that 1 kg is, sorry, don't know why I get using this kg. 1 liter is equivalent to 1,000 cubic centimeters. How about the 15 liters? So when you cross multiply, you're going to have 15 times 1 divided by, 15 times 1,000 divided by 1. Divided by 1, which gives us 15,000. So therefore, the density will be equal to the mass, which is 14,000, divided by the density, the volume, which is 15,000 centimeters cubic. So when you divide that, what are you going to get? 14 divided by 15. Nakupea ngapi?
0.933 recurring.
Sorry, did you say?
0.93 recurring.
0.9333. So meaning that when it's recurring, we can give it into 4 significant figures. So it will be 0.9333. grams per centimeter cubic. So this is the correct answer. There is that one who got 933.33 kg. Up to that point, you are likely to earn, if the question had 4 marks, you are likely to earn 3 and miss 1 for the accuracy, which is the answer. Remember, you are required to give your answer in kilograms, so you will get only 3. If it was 2 marks, you will only get, 3 marks, you will only get 2 and miss 1 for accuracy. So I hope we are okay with that. So you can try another one so that we can you can see. Let's try number 15. It says that 1.5 liters of water, density 1 gram per centimeter cubic, is added to 5 liters of alcohol, density 0.8 grams per centimeter cubic. Calculate the density of the mixture. Tujaribu hiyo. So I hope that we always keep on practicing what we have learned. Don't just relax once you have learned that. You simply keep on piling up the work that we have learned. Once you keep on practicing, it becomes easier to stick into our minds, long-term memory that we will not be able to forget easily. So kama zile vitu tulisoma from the past 3 or 4 weeks or since we started, make sure that you keep on reminding yourself. Mathematics requires a lot of practice. If you relax even 2 days or 3 days without practicing mathematics, you will tend to forget. Are we moving somewhere?
Yeah.
Continue. I can see the response from Charity. Which is 1.192 grams per centimeter cubed. Thank you. Waiting for the response from the rest, so we do it together. I also have a topic or questions on most of the mathematics topics. So if you have any topic that you may want to be handled or you want to get questions on for the purpose of revision, just ask. I will be able to share. Some of them also have or come with their marking scheme, so you can be able to ask for the topic or question that you need. Once you are done, wait for the marking scheme, then you can mark for yourself. Be check where you went wrong and what you need to improve or change. The rest of us, are we making some progress? We are waiting for you. Or can we do it together?
Let's do it together. Then we'll have some questions to do as our homework.
Sorry?
We can do it together. Then give us some homework to go and do it.
Okay. So the question says 15 liters of water density, 1 gram per centimeter cubic is added to 5 liters of alcohol. density 0.8 grams per cubic centimeter. Calculate the density. This is the one that I explained. Like in this case, we have been given the volume, so we need to determine the individual volume. That's the volume of water and also the volume of alcohol. Then we'll be able to get the total volume, and then we find the total volume and the total mass. Then it will be easier for us to find the density. So we know that density of the mixture is given by the total mass all over the total volume. Water, told that 1.5 liters of water, and density is 1 gram per centimeter cubic. So we know that 1 liter is equivalent to 1,000 centimeters cubic. How about 1.5 liters? So that one gives us 1,500 centimeters cubic. So for us to find its mass, will be given by the mass will be given by density times the volume. So the density is 1 gram per centimeter cubic times 1,500. So the mass is 1,500 grams. That is the mass of water. How about the mass of alcohol? Mass of alcohol, we have been given the volume as 5 liters. So when you convert it into centimeters, it becomes 5,000 cubic centimeters, just using the same format or the same conversion unit that we have used here. So we get it as its volume becomes 5,000. So we need to determine its mass. Mass of alcohol will be given by the density times the volume. So the density of this one is 0.8 times 5,000. What does that one give you from your end? 0.8 times 5,000.
800.
Sorry?
800.
0.8 times 5,000.
Oh, sorry. Yeah, I know. I have said for 1,000.
4,000.
4,000. Thank you. So it's 4,000 grams. So then from there now, we need to determine the total density. That's the which will be given by density is equal to total mass over the total volume. So density of the mixture will be equal to the total mass will be 4,000 grams plus 1,500. So tutakuwa hapa na 1,500 plus 4,000 divided by the volume, which is 1,500, which is that the volume of water plus the volume of alcohol, which is 5,000. So when we add the two, we are going to have, in the first scenario, we'll be able to have 5,500 divided by the second one will be 6,500. So when you divide, what did you get? 5,500 divided by 6,500. Natia ngapi?
0.846.
0. We're getting
846. 84615.
0.615.
Hmm.
Thank you. Then now you can be able to express it in 4 significant figures. That's the standard number of significant figures you can give. So it should be 4, at least 4. So we have the final answer as 0.8462 grams per centimeter cubic. So that's what you were supposed to get from that question. The total water density of the mixture is the sum of the individual mass over the sum of the individual volume, which gives us 5,500 divided by 6,500. Ya, kufikia hapo kuna mtu ako na swali ama kuna mtu ako na any question that you may want us to handle before I give you an assignment? I think that you need clarification.
No.
It's well understood.
Me, I have a
Yes.
question.
Yes.
Next topic ni gani ya math ndio tusome mbele alafu so that isituchanganye.
I'm not sure, but I think the next one will be time. Because after this
Or
one,
time.
tunaenda time.
Okay. Sometimes wakati umesoma then mwalimu akuje kwa class, you find some easier, then vitu zenye hukupata time ukisoma you can get mwalimu akisomesha. But like this one,
Yeah.
kuna steps lazima bado tu ni on my side I have to go and sit down so that I can understand very well. Especially converting, ndio kuna challenge kwangu. But I will just get it. Nikiketia chini, I know I'll get it.
Yeah, it's good you do more practice on this. Ndio maana nilisema kwa hesabu, it's important that you make sure that a day doesn't pass without you reminding yourself something.
Yes,
It
yes.
keeps you on. So I don't know, do you have the KLB textbooks ama niwatumie?
Unaweza tutumia mwalimu, unaweza send for us. But the questions zenye unataka tufanye are they the same? Hizi zenye ziko hapa? Ama you send us other questions?
Kuna zile nilikuwa nimetuma last week. Was it on Saturday?
Yes.
Mulizifanya?
Mimi sikufanya, nilikuwa nataka nirudie tena tu kidogo alafu then I do. Alafu nisend because pia niliona kuko na hii yenye tumesoma leo kutafuta density, and then nikaona tu acha tutie topic then I try them.
Yeah, so I will resend them. And also nitawatumia hii KLB textbook ndio pia nyinyi mkuwe nayo, at least mkuwe mnasoma mbele.
Yes. Sawa mwalimu.
I will share all the materials that I have, more especially the textbooks zenye niko nazo. I think I have some for biology, I have some for mathematics, physics and chemistry. I will share them all.
Sawa mwalimu. Alafu
Yes.
mtu anaweza any other question hata kama ni from other topic then akutumie, not necessary kwa hii, but kama mtu anaweza fanya maybe probability alafu akutumie hiyo question, unaweza assist.
Yeah, there's no problem because we are here to assist. You can ask from any topic, so there's no issue.
Okay.
Even if it's from Form 4, you can ask.
Sawa mwalimu.
Yeah. So I think we can stop there for today. Then in the next lesson, you will be informed. I don't know which teacher will be with you. It might be the one or anybody else. Then we'll get to share. So for now, I'm going to share those materials plus the questions. Then you attempt. For the questions that I will share, they have the marking scheme. So once you are done, you ask for the marking scheme so that you will check and see where you have gone wrong or what you have gotten right and what you need to change.
Okay.
Okay.
Okay, thank you for your time. I wish you a good night. We shall proceed as from Monday. Otherwise, have a nice weekend and a good night.
Thank you. Have a nice one too.
Okay, bye.
Bye.